Greetings. This is part 2 of our TRS-80 Model 2 restoration. In part 1, we unpacked the machine, had some damage, addressed a few different issues, identified things that weren't working. But I recommend you watch that if you haven't already. I will leave a link in the description below. So what we're going to do today is, when we left last time, we got the screen up and running, which should give us, make it a bit easier for us to troubleshoot the rest of the machine. And yeah, today is the day where we try to see if it can read anything off a floppy. However, I'm still unsure about the functionality of the disk drive itself. So what I'm going to do is use a Gotek, which is flashed with HXC software, which works. I use this one to test machines when I don't have a working disk drive, and it seems to work well, but I have never used this with a Model 2 because this is my first Model 2. So what we're going to do is turn on this guy and select a TRS-DOS 2.0 image, which was Radio Shack's own DOS supplied with this machine. Now I have the data cable to the physical floppy disconnected. We'll leave that out of the equation for now. You then need a converter board to go from the 50-pin floppy to a 34-pin connector that the Gotek requires. Now they sell these, but during the holiday season I couldn't get one quickly. So I figured it wouldn't be a bad idea to put one together myself, which I did, which also would give me a much better understanding of how different the 8-inch drive signals may be to other disk drives, like a 5 1/4. It has some selectors where I can select the drive ID of this guy, and the other one implemented is whether you want a disk change signal or just a ready signal if a disk is inserted. And that should give us an environment where we can try to boot, where this is the first drive, and see if we can boot TRS-DOS on this machine without this being another source of problems. Okay, let's see what gives. Power on. See a blinking cursor. Okay. So what we saw was it said 64K of memory, and that is part of the boot up self-test, but the RAM test is not on the EEPROM on the CPU card, but rather on the starting sector of the disk image. So what that tells us is it was able to read the disk, well, at least the first few sectors, run the memory test, and then as it's tried to continue, it's telling us boot error DM13, and DM stands for DMA. So what DMA does is it's a way to transfer data very quickly from one component to another in your system without having the processor do it byte by byte. You set up a source, a destination, and then the processor tells the DMA chip to go ahead and move data from A to B and relinquishes the bus, all the buses. So it essentially goes to sleep, while the DMA does its business. And when the DMA is done, it wakes up the CPU and says, okay, the bus is yours again. You may continue at what it was you were doing. I did some research on this error, and it points you in several directions. The main thing that the online community seems to report is that there's something wrong with the floppy controller, because the DMA error shouldn't be an error with DMA, because DMA tries to get the data, and if it times out, i.e. the disk no data has arrived from the disk, then it just reports and says, hey, the DMA didn't give us any data. But that doesn't necessarily mean that it's the DMA chip that's causing the problem. In order to further analyze this, I needed a way to probe these cards, the disk controller and the CPU card. But as you can see, it's kind of difficult to do. So what I came up with is basically take a card that I wanted to probe, put it in the leftmost slot, move all of the remaining cards to the right, and that gave me just enough space in here to put a chip clip on the component I was checking and stick a oscilloscope probe in there. But let's take the cards out and talk about what we found. So here we have the CPU card. Trying to read the chips was a bit of a pain because Radio Shack decided to use house numbers on them. So it doesn't have, it says Z80, but then there's a bunch of numbers there, and well, it says Zilog actually, and you don't really know. So I had to identify the chips first, and came up with that. This is the CPU, this is the DMA, CTC, which is a counter timer, and SIO, which is a dual serial I/O. So the CPU card also supplies a serial port, which you can plug into here. And using the setup I showed you earlier to be able to probe this, I didn't really know what I was looking for. I was checking to see if the DMA chip is getting selected, if just kind of aimlessly poking around and grasping at straws. I did find some weird behavior on this glue logic over here, or at least I thought it was weird behavior. Duly removed these chips and put them in a chip tester, and they both tested good. Regardless of that, I put in new chips, put everything back together, and nothing had changed. The only other thing that is worth pointing out is that, this is the ROM. It's a 2K ROM, EEPROM, and all this does is it basically tries to read the disk. It puts up the insert diskette message if it doesn't see a disk-ready signal, and once it sees a disk-ready signal, it goes ahead and tries to read the beginning, the first, I think the boot sector, and then jumps to it. And that's when we saw like the 64K memory message and stuff. That's actually executing code off the disk. This thing is too small. It's mostly set up that if it's unable to read the floppy disk, it will display errors telling you what it thinks it is. So the DM error we're getting is actually not coming out of here, but is coming off of the beginning sectors of TRS-80. Does that help us with the diagnosis? It should, but not really. So anyway, I put effort into this, and that didn't change anything. Next, we'll have a look at the disk controller card. The disk controller card is just that. It handles disk control, and it has two major chips. One is the Western Digital 1791 disk controller chip that handles data transfers and basically talks to the CPU. And we also have a Zilog PIA, or PIO, which is a general purpose I/O chip. This basically handles selecting the proper drive, and then all the other signals to control the floppy come out of here. Another advice that was given on the internet was that most likely this thing will go bad on you. You can still find these. There are not too many of them around, but supposedly this was a great point of failure. The PIO wasn't even mentioned. So yeah, I put it in same way I had the CPU card in, checked for signals, and everything seemed to be okay. Things were getting selected, but there was no data flow happening coming out of this, coming out of the disk controller. So I was being told to read something. Now it obviously did read something, which was the initial sector, but I guess as it tried to read, when that code was executed and it tried to read larger blocks of code, it failed. But again, probing around this didn't yield anything of use. For completeness, let's look at the other two cards that I'm not suspecting of anything bad going on, but this is a 64K memory card. It's got a bunch of 4116, 16K by 1 chips, and these don't have a really good reliability record, but obviously they pass the memory test every single time. So I don't think that the problem lies in here, but here it is. This is what you need to put 16K into a Model 2. I think you can add more memory cards to it, because these in the standard configuration came with only 32K, which is the upper 2 rows. But I think you could add more cards and probably get this up to, what, 128K? But good luck finding one of those. And finally, we have the keyboard display card. And the major parts on here are, it uses a Motorola 6845 display chip. So unlike the Model 1 that does it all in nickel and dime hardware, this chip it has screen memory over here. The processor communicates with it. It scans the memory and outputs a horizontal sync, vertical sync, and the actual video signal. I probed around this one too, trying to remember if I did anything with it, but no, it really wasn't necessary to do anything with it. This is the character generator ROM, and that pretty much sums up what's going on with all the cards. At this point I had made no progress. Here's the CPU card again, and while sitting here trying to think what to do next, I kind of figured, well, the computer's telling you something. The internet's telling you it's something else. But what if the computer isn't lying? i.e., what if the DMA chip's bad? Well, let's put a brand spanking new Z80A DMA chip into that slot and see if that changes anything. Okay, the DMA chip was replaced. Thank you for socketing that, Radio Shack. And we still got TRS-DOS selected over here. So let's see if we are able to pass the hardware test this time, and here we go. Cursor. Oh, initializing and no error. Come on. And there you go. We just booted TRS-DOS 2.0. And it's waiting for us to enter the date. This obviously, well, doesn't have an active real-time clock, but it booted. So for grins, let's try another image. Oh, but you say, come on, enter the date. Want to see this thing fully booted. Yeah, so I'd really like to do that, but the keyboard's dead. Completely. Not a single key works on it. But note that I'm not panicking, because another similarity between this machine and the Model 3 is they use the same technology in the keyboards. These are capacitive rather than, switch contact based, and there is some foam involved in keeping that mechanism running, and the foam completely disintegrates. And I will show you in a minute why that happens, what the foam has to do with a capacitive keyboard. But let's try it anyway. We can't get any further than the sign-up screen, but wouldn't it be cool to see if we have something else that can boot? So let's see, can we boot CP/M? Well, I think that's Lifeboat CP/M. So let's see. Let's see, this goes through the same song and dance. No, it doesn't. It goes straight into CP/M. And it goes into a word processor. This is Is this WordStar? I don't know, but again, it booted this one, and then I'm going to show you the one that boots really fast, which is probably going to be my favorite, and that is, so let's go back, DOS Plus. This, which I am assuming is the latest version available. Now that was fast, don't you agree? Well, and this gets stuck on the date. So let's have a look at the keyboard and see what we can do there. So here's the keyboard, and as I mentioned, I've done this procedure on a Model 3 computer, which is very similar to this, but not interchangeable, because this is a smart keyboard that actually scans and just returns key presses, similar to the way an IBM PC keyboard works. So I couldn't, I couldn't just plug in a Model 3 keyboard and use it, but I'm not going into deep detail on this because there are others who have done this online, and if you search for Model 2 keyboard repair, there'll be a few examples of what the details look like. It's fiddly work, but I'll go through briefly of how this is supposed to work. So under each key, there's a sandwich like this. It's called a foam and foil pad. It's got foil on top. It's got a little plastic disc on the bottom and some foam in the middle, kind of like a sandwich, where the foam is, I guess, the processed meat that's in it. This foam tends to degrade. Actually not degrade, it's mostly disappears. It just disintegrates. So I opened up the keyboard and I removed what was in there and ended up with a bag like this that had, as you can see, not a whole lot of foam anymore. There's some foam stuck to the plastic discs, but not much left in here. And I think what's happening is when the foam degrades or disintegrates, the processor inside of this sees key closures because there's no longer something maintaining the distance between that pad and a PCB underneath that has copper contacts on it. The principle is the copper contact is one pole of a capacitor, and the foil, if I can grab this guy, he doesn't want to be grabbed, and the foil is the other pole of a capacitor. And in the rest position, there's a specific distance between the foil and the contact on the PCB underneath. Now when you press a key, it compresses the foam and changes the distance between the foil and the contact on the keyboard, resulting in a different capacitance value. Now that lends itself, of course, this keyboard is not touch sensitive or anything like that, but it would lend itself to something like that if you had electronics that had a high enough resolution to read different capacitance values. However, in this case, it doesn't have it, and the capacitive, it basically works as an on-off switch. Either the foil is really close to the contact on the PCB with the key pressed, or with the key not pressed, it's a certain distance from it. But I think the way this is calibrated or used is, again, it's a digital fashion. Either you have the capacitance, there's a different capacitive value between key up and key down, and the chips in there basically detect either a closure or an open key. And what was happening is generally the processor in there just saw a whole bunch of keys closed and said, I'm going to wait for all of these keys to get released, and then I'll start working. But that would never happen with the disintegrated stuff. So actually, even if you have a keyboard that has some keys working, it's not enough, because the problem is the disintegrated foam keys are going to mess up the processor in there. So to the rescue comes the Tech-Select kit. Comes with about, 110 pads, and you just go in, remove all the old pads, and put a whole set of new ones in there. It's kind of fiddly work because the way these are held in place is the underneath is a plastic disc. And in the key housing, or in the, underneath the keys, every position for a key has 4 little plastic tabs that this plastic disc has to snap into. So it's fiddly, to say the least, to get them all in and then make sure that all 4 tabs are engaged on this, because if they're not, the pad's going to move or it's going to rotate and it's going to cause you keyboard problems. So it takes a little while to do it. But that's what I did to this. I replaced all of these pads. Oh, and by the way, yes, Texelec has some great products, but not a sponsor. But could be if they wanted to. Anyway, my first try was kind of interesting because it took a while to get the replacement kit. So I played around with the idea of building my own. And I came up first with something like this. There was too much foam in the middle. Reusing the little plastic disc from underneath, but just using like a HVAC metallic tape for the foil on top. And there was this was too high. It didn't work at all. So I made a second revision where I reduced the amount of foam, made it about the same height as the replacement ones. Took me quite a while, and it didn't work. Well, it did kind of work. At one point, some of the keys that I put these pads under, whenever you press the key, it would show you 7 random key presses that changed every time you press the key. So I think the disintegrated ones were messing with the logic big time. I guess I could have gone ahead and made, 76 of these and seen if that would work, but even for me that was too much, so I just bided my time till the proper kit arrived. And let's see if we fix the keyboard and can now do useful stuff with it. Keyboard's back in its place, and let's go back and select TRS-DOS. See if I can enter the date now. And lift off. Come on. Well, this isn't very exciting because we've already seen it work. But weird things do happen. Okay. So if we look at this now, one simple way to see if the keyboard's alive at all, you press the caps key and it lights up. It works. So the electronics in here, I mean the keyboard's getting scanned. Things are running because there's some odd chips in there. If those go bad, well, let's deal with it if we have to. But enter the date, and it's very strict about the date, the format. So let's do, look at it, single click, no bounce, very nice. Okay, it took the date, it looks right. Will it accept it? Yes. The time is more lenient. You can just hit enter and we're in. Now, I don't know if the camera shows this well, but there's some horizontal jitter in the picture, and I've diagnosed it. It's basically the cooling fan. Because it's visible, I mean, if it was a high frequency jitter, you would just see the characters. Because it's like going a pixel left and right, it would look like it was out of focus. But I think this is like 60 hertz it's doing it at, because it's not throwing the screen out of focus, but it is having this annoying jitter in there. And disconnecting the cooling fan completely fixed this. So I got to find another fan. Now, I'm not talking about the screen flicker here, but rather the image moving left and right at what I think could be 60 hertz. But yeah, so let's see. I did go in, I tested every single key, and they all work perfectly. So now, let's see if we can get a directory. And it errors out. And the reason it errors out is TRS-DOS insists on uppercase. So we press caps lock and do it again. And we read the directory off of the Gotek. See if there's anything interesting on here. Well, not really, but so the machine, well, the input device now works. And I think now we can finally get to the point of seeing if we can load anything off the real floppy drive. Well, this is probably a good point to end this episode, because I think the testing of this drive is going to involve some effort, and I'm going to leave that to part 3. This thing is truly massive, with the hub spindle running all the time, and very impressive. But we'll find out next time if it's not just impressive but actually useful. Thanks for watching. See you next time.